law of cooling. The temperature difference in any situation results from energy flow into the system or energy flow from the system to the surroundings. Newton's law of cooling explains how the temperature of a body relates to its time of cooling. It is named after the famous physicist Sir Isaac Newton. Now, let's study the relationship between temperature of a body and time as it cools by radiating heat. Principle. According to Newton's law of cooling, the rate of cooling of a hot body is directly proportional to the temperature difference between the body and its surroundings. That is, d theta by dt is directly proportional to theta minus theta 0, where d theta by dt is the rate of cooling. Theta is the mean temperature of the hot body when it cools through a certain range. Theta 0 is the temperature of the surroundings. That is, d theta by dt is equal to k into theta minus theta 0, where k is the proportionality constant. That is, d theta by theta minus theta 0 is equal to k into dt. Therefore, log theta minus theta 0 is equal to kt plus c, where c is the constant of integration. Therefore, theta is equal to theta 0 plus e raised to kt. The graph between temperature, theta, and time, t, will be an exponential curve, which is the cooling curve. Materials required: copper calorimeter, stirrer, wooden box with a clamp and stand, thermometer, stopwatch, hot water of about 80 degrees Celsius. Procedure: fill about 2/3 of the copper calorimeter containing stirrer with hot water of about 80 degrees Celsius. Place the calorimeter inside the wooden box. The space between the wooden box and calorimeter is filled with cotton to avoid heat loss. Close the wooden box with its lid. Suspend the thermometer inside the hot water in the calorimeter from the clamp and stand. Stir water continuously to make it cool uniformly. When the temperature of hot water falls to 70 degrees Celsius, start the stopwatch. Note the temperature reading every 5 minutes. Continue the time temperature observation till the temperature becomes constant. Plot a graph between time along x-axis and temperature along y-axis. This graph is called the cooling curve. The graph is an exponential curve and it shows that the temperature falls quickly at the beginning and then slowly as the difference of temperature goes on decreasing. This verifies Newton's law of cooling. Applications: forensic experts use Newton's law of cooling for the determination of time of death of a victim. Newton's law of cooling is used for studying how fast a water heater cools down when it is turned off.